Why do we need to identify file formats accurately? Why the current tools we are using are not, are sometimes wrong, and how we can do better. So my name is Philippe Lagadec, and in the next 25 minutes I will cover those questions. But first, imagine you are in a game, okay? In this game, your goal is to, you have a person in front of you that you don't know, and your goal is to guess their nationality, okay? So, and for this, you have two choices. Either you can ask questions, or you can check their passports, okay? Let's try this game. So I will pick someone randomly in the audience. Please, Alex, can you jump? Okay, I hear you have a slight French accent, a bit like me, so I guess you're a French speaker. So I will ask you a few questions to try to guess your nationality.
Sure.
So you could be either Belgian or French or Swiss or Canadian, maybe. So how do you pronounce that number?
Of course, 80.
Yes, good. So if you say 80, you're not Swiss. Otherwise, you would have said octante. Okay. Now this one.
It depends.
Oh.
So if I talk to Paul over there, I would say in French 90. But if I talk with some other people I know, it would be 90.
Okay, so but usually you would say no, not. So you would you sound you sound more Belgian than French. And this one.
Wheat.
Yes. Okay, so you're obviously Belgian because a French guy would say huit. Okay, so good. So using those questions, I managed to guess your nationality. But if you had been a true polyglot, no pun intended, then it would have been much more difficult to find your actual nationality. But remember, in the game, I said that you also had another choice. You could check the passport. And if I could check your passport, then it would be more accurate, more obvious, right?
Except it's a fake passport, but...
Yes, of course. Okay, well,
okay.
Thank you, Alex.
Thank you.
Okay, so let's keep that for later. So now we are going to do a little quiz. Okay, what is the true format of this file? Yeah, you don't see everything. Anyway, there is just one last line, but okay. So if you tell me that this file is a batch file, you're right. If you tell me it's HTML, you are also right. Ouais. And if you tell me it's a PDF file, well, you're also right. It's any of these formats. But to answer the question, we miss key information here. What is it? Sorry? Well, yes, and what are we missing for that? Yes. The extension, yes. We are missing the file name with the extension. Why is that? It's because operating systems today, how do they open a file? Well, they check the extension. That's how they choose which application to open the file. And it works on Windows, on macOS, and on Linux also. So I can just show you, because I know many people think that on Linux we use libmagic to determine how to open a file. But in fact here, I took this file. If I name it .bat, if I double-click on it in Linux, it will open the text editor, because it's a batch file. Okay? It's a Windows file. Now, if I take the same file with a .html, I just renamed it. I open the file, and it will open in the browser and execute JavaScript code. Okay? But it's the same file. It's just a different extension. And now if I take the same file again and rename it .pdf, I double-click, and it opens in the PDF viewer. So you see, even on Linux, it's the extension that drives which application to open a file. So it's the extension that defines what is the format of the file, not the content. Okay? So let's go back to the presentation. So why do we need to identify file formats accurately? Well, in many places in IT and especially in cybersecurity, we need to first identify the format of the file to decide what to do with it. And I work at Glimpse, which is a company which develops malware detection and analysis platform. The first thing we do with the file, we need to identify its format, and then we can decide which scanning engine we run to analyze the file. And if we get it wrong, we can either have a false negative if we miss some malware and the malware can go through because we have not scanned it correctly, or in the opposite case, we can, with the wrong format, we can make a false positive if we detect it too much. So it's really key to identify the file format properly to be able to do, our job of malware detection. Okay. So today, how do we identify file formats? So in many cases, people use the file tool, which is based on the libmagic library. There are some variants of it. You have also the TRID tool and others. Some people use Yara rules to check the file formats. And also, more recently, Google published a tool called Magika, which is based on neural networks to identify a file format. Okay, so who in this room has already used a libmagic or file to identify a file? Yes, a lot. Who has used the Magika? Yeah, quite a few also. Yes. So it's very, these tools are used everywhere. In fact, in many platforms, if you use VirusTotal or Malware Bazaar, for example, all these platforms which do malware detection or analysis, they use libmagic and Magika to find out which file format it is. So how does libmagic work? libmagic works with a rule engine. It can recognize thousands of file formats, and for every format there are rules which will look for specific bytes located at specific locations in the file, or it will look for specific strings, or it can even use regular expressions to look for specific patterns. So that's how libmagic works, and it will run all those rules and find out the one that matches first. Yes. So this is great for binary formats which are well structured. So if you take an executable file, for example, it has a specific MZ header at the beginning. If you take a legacy Word document, it has also a very specific marker. So it works very well for binary formats. But for text formats such as scripts, it really sucks. It does not, for example, if you take PowerShell scripts, libmagic will not recognize them. It will tell you it's text. So it's not very useful for that. Now we have Magika, which is the new kid on the block. Magika is much better at recognizing some file formats. So how does it work? It takes the file, it takes the first kilobyte and the last kilobyte of the file. And it uses a tokenizer to translate that into tokens, which then run into a neural network, and it will give you. You don't see it. Okay. Well, anyway, so it takes the first kilobyte and the last kilobyte, runs into a neural network, and then it can identify up to 200 file formats. Okay. So this works really great on text formats compared to libmagic. Google have published a paper a couple years ago saying that on a binary format it's 4% better in recognition than libmagic, and on a text format it's 20% better. So Magika, unlike libmagic, is able to recognize PowerShell and other script formats. So it's really great. But it doesn't always work as expected. For example, here I took a PDF file on Malware Bazaar. If I run it with a file tool which uses libmagic, it will tell me that it's unknown binary data, so octet stream. Now if I run it with Magika, it will tell me that it's a certificate file. So none of them is able to tell me it's a PDF, but it's an actual PDF. If I open it in a viewer, I get a PDF. So why is that? If you look inside the file, you see here that there are some random bytes before the .pdf header. Okay, so it looks strange. Actually, this is not in the specification of PDF, but since the 90s, when PDF was born, all the PDF viewers, including the recent ones, they allow up to 1 kilobyte of random data before the start of the PDF file. Why is that? It looks a bit strange. Well, it's because in the 90s, the web browsers at the time, they did not know about PDF. They didn't know how to open a PDF. So it was used to insert a small HTML page so that the browser could tell you where to download Adobe Reader. That's why. But today, it's still possible to put 1 kilobyte of data before the PDF header, and then it will fool Magika and Imagic. They will not see it's a PDF. Another example. So this one was reported by the Japanese CERT in 2023. This file, when you look at it, it starts with a PDF structure, and then there is something else behind. If you run it in a LibMagic or Magika, it will tell you that it's a PDF file because it starts with a proper structure of PDF. But the file is named .doc. So when you double click on it, it opens in Word, not in a PDF viewer. And in Word, it will find out that there are some macros, VBA macros, and it will run the malicious code. So again, it's the file extension that drives what happens, not the content. Another example from 2020. In this case, these were MSI files, so Windows installers, from legitimate software, so signed MSI files, which are completely legit. But after that, they appended a jar file, so a Java code, which is malicious. And if you run it in LibMagic, it will tell you it's an MSI file because it starts with an MSI file. If you run it in Magika, there are several samples. Sometimes it tells you it's jar, sometimes MSI, it depends. But if you open it, it's a .jar file, so the malicious Java code runs. Okay, so just to show you some examples of real-life malware that abuses these things. Okay, so I told you that, there is another hard case, is how to identify script format. PowerShell, JavaScript, Batch, shell scripts, whatever. In fact, they are very hard to identify by content only. I don't know if you have already looked at malicious PowerShell files. They can be very, very obfuscated. It's very difficult to tell with a human look what it is. And so it's also difficult for tools. And for us, at Glimpse, we have developed PowerShell LLM, which is a malware detection model for PowerShell. So it will analyze the PowerShell code and tell you if it's malware or not. It works very well, but you need to feed it with actual PowerShell. Because if we give it something else, the results are unpredictable. And so, for example, a couple months ago, one of my colleagues sent me a false positive of our PowerShell detection. If I look at the file, so here you can see that it's actually base 64 encoding. If you decode it, it's a simple text message, just encoded in base 64. So it's pure text. But if you run it with Magika, it tells you it's PowerShell. Why? In fact, it turns out that when Google trained Magika, they have a very large data set of files, and it turns out that many PowerShell scripts include base 64. So when Magika sees base 64, in some cases, not all the time, it may tell you it's PowerShell, but it's not. So it's very difficult to, it's not very reliable in this case. Another weakness, recently in October, there's a very brand new paper by Google researchers. They have applied adversarial machine learning techniques to the Magika model. And so what they did, they tried to bypass Magika because Magika is used at Google to protect Gmail. So when Gmail receives an email, it will run Magika to identify malware. And if you manage to fool Magika, you can bypass this malware detection. And their conclusion after doing all their tests is that they managed to bypass Magika 90% of the time by just changing 13 bytes in the file at specific places. So it means that if you want to bypass it, you can. Okay, but there's more. You remember I showed you how Magika works. It takes the first kilobyte and the last kilobyte. Okay? But then, what happens to the rest of the file? It's simply ignored. It's discarded. Magika does not look at the middle of the file. Okay, so I was thinking, now I have a malicious PowerShell script. In a script, you can add as much white space as you want. Okay? So what happens if I put more than 1 kilobyte of white space at the beginning and more than 1 kilobyte of white space at the end? Okay, let's try. So I took a malicious PowerShell script, okay, from Malware Bazaar. So this is malicious script. If I run it with Magika, it tells me it's PowerShell, so it works well. Okay. Now, what happens if I take the same script, but I append 4 kilobytes of white space before and after the script? So you see here, oops, it's white space, but we see there is still the PowerShell script and white space before and after. Okay. Now, if I run Magika, oops, on this modified script, text. So then Magika does not see its PowerShell. Okay. So then I tried this technique. I took 1,000 scripts from Malware Bazaar, and in 100% of the cases, Magika told me it was text. So it means that this technique works every time. And I tried the same for JavaScript, the same. So there's a very easy bypass for scripts on Magika. Okay, so just to recap, what have we seen? There are several cases where the current solutions don't work very well. If you have slightly malformed files exploiting parser's flexibility like PDF, if you have polyglot files like the first example I showed you with different files in one, and the main thing for me is if you have unstructured data that are hard to identify, the tools we have are often wrong, and Magika, as you can see, can be bypassed if you know which formats you are using. So all this is due to a fundamental flaw in these tools. It's because they are trying to guess the file format by only looking at the content. That's why it's so difficult. Okay, so how can we do better? Well, remember the game we played at the beginning with Alex? I could either ask him questions or check his passport. So what's the best way to guess his nationality? It's just the passport. For files, the extension is the passport. If you look at the extension doesn't lie because that's how the operating systems choose how to open a file. So the true file format comes from the extension. Extensions don't lie. So I was thinking, this has been bothering me for many years, but I was looking at how can we do a new algorithm which gives better result to identify file format. Yes, here again. Sorry, yes, here you can see better. Okay, so this is an algorithm that I designed to try to address this issue. So first, we look at the extension. Is it a known extension for a format that we know? So for example, if it's a .doc, yes, then we will list the potential formats matching this extension. So if it's a .doc, it could be either a Word document or an RTF document or text. Then, for each of those formats that we have selected, we run a specific matcher, which is kind of a small parser. It will try to see, is it Word, is it RTF or text? Then in this case, if I find that the content looks like RTF and the extension is RTF, then we have identified the format with a very high confidence because everything looks the same and is connected. Whereas if the content does not match the extension, then we have two cases. If it's an unstructured format like a script, well, we know that we cannot rely on existing tools because it's a very hard problem to identify these unstructured formats. In this case, then we just trust the extension, and then we identify the format from the extension with a medium confidence. Now, if we have a lot of files also which have been renamed, or they have no extension, or they have an extension which is unknown. In that case, yes, we have to fall back to the normal, to the classic way of doing by using libmagic and Magika. And depending if it's a binary or a text format, we can use the one or the other to identify the format with a medium-low confidence. So using this algorithm, we have a much better result. And so I started to implement this. Yes, I started to implement this algorithm in my tool called the Ftguess for file type guessing. So the work is not finished yet, so it's still quite experimental, work in progress. Originally, Ftguess was just a tool in OLE tools to better identify Microsoft Office formats, to be more precise than libmagic. But now I'm extending this tool by implementing this new algorithm and supporting many more formats. So you can test this tool by using the command that I showed because it's still a development branch, and you can test it that way by running Ftguess in a strict mode. So here's how it looks when you run Ftguess on the malformed PDF that I showed you before. So it managed to identify it by checking that the extension matches the content. So what I plan to do on Ftguess in the future, so I need to finish implementing the full algorithm that I defined. I will test it on large datasets, both on malware and on legitimate files, and testing all the tricky cases that I mentioned before. And I might develop a Go version for better performance. For now, I'm prototyping in Python, but this kind of tool needs to be really fast. So we need to use a faster language. One thing I wanted to mention, for malware analysis, many malware analysts have the habit of renaming files because when you have malware, you don't want to accidentally open it. So usually people rename the file and remove the extension. Then you lose the main information. So one way to do it would be to keep the file name file.ext, but add .infected behind. So then it will never open if you double click on it, but you can still have the information about the original file name. So that would be much better. Okay. So to finish, key takeaways that I want you to remember. We do need to identify file formats more accurately than what we are doing today. File extensions don't lie because that's how operating systems open files. So do not rename suspicious samples. Keep the original file name. The current tools like libmagic and Magika, as you have seen, only look at file contents. Sometimes it's just wrong. And you can even bypass Magika and libmagic if you know how to do it. And we can do better by checking both the file extension and the contents. Okay, so if you want to contact me, here is my information. And also, if you're interested in glimpse for malware detection analysis backed by AI, you can also contact me.
Thanks a lot. I'll try much. We have questions now.
Yes, and
I come.
I have stickers for good questions.
Thank you for your presentation. It was really interesting. I have a question because you know a bit is like I'm re-implementing libmagic in Rust, and so I dug like a lot in the libmagic format. And inside this rule format, you have the information about the file extension.
Right.
It's just that it's not used by libmagic, but in theory, it could be used like to both like speed up the detection, because you can first try the rules where the extension is actually specified.
Right.
And so, yeah, just what is like do you think it's like a good idea, like to do that, like first trying to identify based on libmagic, based on the extension included in the libmagic rule, for instance?
Yes, I mean, that's how I would do it.
Okay.
As you said, it's much faster because you look at the extension, and instead of checking thousands of formats, you only need to look at the 5 or 6 formats that match the extension. So yes, it will be much faster. But then, if it doesn't work, then you need to go back to the full
we need
set.
to fall back. Yeah, but because, what it is, how it is done so far is like, is done based on the strength of each rule. So rules who have like more definitions get assessed first. And sometimes it's not the one matching the extension, and that's maybe where you can fool the libmagic. But I think it was an original will from the libmagic developers who actually want to identify files based on the content, right, and absolutely not on the extension. I don't know why, but apparently that's what I read. The people didn't want to do that at that time.
I think it's the Unix philosophy at the beginning. They originally in Unix you didn't care about the extension. It was like a Windows thing. But it turns out that in the recent Linux distributions, it's because of the window managers, GNOME, KDE, XFC. They are all now following the same standard. And in fact, they don't use file anymore to open a file. They use XDG open instead. And XDG open, I don't know if you have looked at it. It has a lot of rules, and in fact, XDG open looks at the extension first. And then the content sometimes. But that's why, I mean, the philosophy has changed on Linux because of the window managers. Okay. And that's why today, when you double-click on a file, it looks at the extension.
Okay. So it is not wrong, like, to use the extension?
No. So I think you're right. We could improve libmagic by implementing the algorithm I just mentioned. Yes.
Okay. Thank you.
Is there another question? Oh, yeah.
Is it good to only rely on the file name extension, because otherwise you could maybe hide payloads in other files, and
right,
because they don't need the correct file name extension? And so did you think about possibly scanning for all the possible formats that may match a file? In the example, for example, the free formats that could
yes. So you're right. There's something I didn't mention. Here, I'm mostly, when we talk about malware, I was mostly focusing on the first stage of malware. When you receive an email with a malicious attachment, or when you download a malicious file from a website or something like that, the first stage of the malware needs to execute. So it needs to have the right extension, okay? But when this first stage of malware runs in memory, then it can get other files and rename them or do something. So the second stage of the malware, it can have a wrong extension. And then, yes, of course, the algorithm doesn't work anymore in this case. So the algorithm I showed is mostly for first stage malware or for legitimate files. Right.
Okay. Oh, no, I have no time for the last one, but you could find this guy with beer later. Thank you. Thanks a lot, Philippe.
Yeah. Thank you.